Hey everybody, today I'm going to be talking about a little bit more of some real analysis. So we're going to specifically talk about the supremum, the infimum, the limit superior, and the limit inferior of a sequence. Alright, so I'm basically going to define them for you and show you some examples, just give you some intuition for what's going on. I'll call the sequence X, and I will say it is equal to, I don't know, we take like 1 over n for n in the natural numbers. And for this video, I'm assuming that 0 is not a natural number, okay? So, this is our sequence X, and let's kind of plot it. Let's start with n equals 1, that's going to be up here. N equals 2 is going to be 1 over 2, so a half. N equals 3 is going to be 1/3, so it's going to look kind of like this. N equals 4 is a quarter, so it's going to look a little smaller. And a fifth is going to look a little smaller. And you can see this general pattern of it kind of like leveling off as it comes closer. And as we go to infinity, I think you can agree that the limit, as n approaches infinity, of x is equal to 0. Because as we keep going, as we go to infinity, this is going to keep getting smaller and smaller. Now, is it going to reach 0? No. And I'll show you why. Because if we take 1 over n and we see, is this equal to 0 at any point? So I'm going to put a question mark there because that's what we're trying to find. Well, if we multiply both sides by n, we get that 1 equals 0. And this is certainly not true, so there is no point where this is actually equal to 0. However, it approaches 0. So would you say that there is a smallest element of this set? Well, not really, because we're not going to get a solid number, because this is going to keep going to infinity, and as this gets bigger and bigger, as the denominator gets bigger and bigger, the whole number is going to get smaller and smaller. And we have no end. There is no final number that we are going to plug in for n, which means that there is no actual smallest element. So what's 0? Well, 0 is the limit of our sequence, but it's more than that. It's also what's known as the infimum. So if we take the infimum of x, and we can just denote it like that, the infimum of x, that is equal to 0. The infimum is also thought of as the greatest lower bound. Okay, so we're going to take the lower bound of the sequence, but the greatest one, the one that's like you can have a bunch of lower bounds for this. For example, -1 is a lower bound to the sequence, because again, there's no point where 1 over n equals -1, because I can be like this, and then I can multiply both sides by n, and I get that 1 is equal to -n. And then I can say -1 is equal to n, but n is not equal to -1 because that's not a natural number, so this is not true. So, any negative number was not going to work for that reason. So, -1 is a valid lower bound, but so is -2, -5, or -infinity, technically. So, the infimum is basically the highest we can go, that's the closest to the sequence, and it can actually be in the sequence. It's okay if it's in the sequence. If we do have a smallest, if we do have like a smallest element here that's in the set, that's a minimal element, then the infimum is going to be equal to that smallest element. So let me give an example. If we have, I'll say x sub capital N, if this is equal to, if we have the same sequence, but I'm saying that n is between 1 and capital N, or we could think of capital N as just some large number, whatever, or it could be small, it doesn't matter. It's going to be the same sequence, except it's going to end at some point, because our sequence is going to be between 1 over capital N. Oops, it's going to be like that, and then at the highest end, it's going to be 1 over 1, which is just 1, right? So we can think of it this way, that our sequence is bounded like this, and I can say this because this is monotonically decreasing. In other words, it just keeps decreasing. There's no point where it increases, so our endpoints are the greatest, are the least and biggest elements in the set. So in this case, 1 over n is actually in our set. So therefore the infimum of x sub n is equal to 1 over n, or 1 over capital N. Now that's the infimum. What about the supremum? Well, the supremum is the same thing, except it is the least upper bound, and in this case it's going to be 1. So I'm going to say this is the least upper bound, and it's pretty much the same thing, just from the other side. So does this sequence have a supremum, this x over here? Well, yeah, because it has a greatest element. So in this case, the supremum of x is equal to 1. And so it is in this case as well. Now, what if we take something like, I don't know, the sequence of integers, or natural numbers, I mean. So again, we are saying that 0 is not a natural number. So 1 is the smallest natural number according to my definition. So the infimum of the set of natural numbers is 1, but the supremum of the set of natural numbers, it actually doesn't exist. So the supremum of the natural numbers does not exist because there is no upper bound to the natural numbers. With the integers, there is no lower bound either for them, and so so the integers do not have an infimum or supremum. So that's pretty much the idea of these. There are a bunch of other examples. I will link the Wikipedia article to the infimum and supremum, just to kind of show you some other examples and some more explanations and stuff like that if you're curious. So now we're going to discuss the limit superior and the limit inferior. Okay, so here I have this sequence, and I know I made it continuous, but I didn't want to put all the dots and whatever. And sorry it's not that great of a picture. There's actually a really good picture on Wikipedia that I will also link that Wikipedia article below, and you can see for yourself. But pretty much this is the idea of what's going on with the limit superior and the limit inferior. So we can think of the limit inferior as the limit of the inferior, and the limit superior is the limit of the superior. And so basically we can take the superior of x sub, or the inferior of x sub n, and we're taking it for m, values of m that are greater than or equal to n, and then we're taking n to go to infinity. So this is kind of the idea of what's going on. So pictorially, we can say, we can realize that this limit is, or this sequence has this range up here, and then it's getting smaller and more narrow. And so this is what the limit superior and limit inferior tell us. They basically say, as we go to infinity, it looks like we're going to have a range that's about this, right? And we converge to a particular range. So if I can draw a straight line going from across here, I'll start over here, and, oh man, I already messed it up, but something like this, that line is the limit superior, because it's kind of the, we're taking the superior as it goes to infinity, because each of these are the superiors for the particular values there. If we take, like if we take this region, the superior is there. We take this region, superior is there. And the superior is converging to this particular value. And so is the inferior. We take something like this, and we see that this range is going. And so we get inferior, inferior, and this is going to keep approaching the the limit superior and the limit inferior, like that. So I hope this kind of helps you understand what's going on. If you want more information, I will leave a link to the Wikipedia articles down below. So I hope you guys enjoyed. Thank you so much for watching, and I'll see you in the next video. Bye guys!